Welcome to our deep dive. We're taking a closer look at cocktail party chemistry, specifically episode 179, The Chemistry of Air, What We Breathe. We'll explore some cool facts, perfect for sparking conversations, and dropping some knowledge at your next get-together.
It's funny, right? We breathe air constantly, but most of us never really stop and think about what it actually is. This episode breaks it down in a way that's both interesting and kind of mind-blowing.
So let's get into it. We know air is, essential for life and all, but what exactly are we breathing in?
Well, it's mostly nitrogen and oxygen, with a few other gases mixed in, kind of like a recipe, with each ingredient playing a crucial role.
Right. Nitrogen is the most abundant, I think. But it's always felt kind of blah to me. Not as exciting as oxygen, with all that energy and fire. What's the deal with nitrogen?
True, nitrogen gas is pretty unreactive. But don't underestimate it. Think of it as the base of our atmosphere. It dilutes the oxygen, making it safe to breathe. Plus, it's a key ingredient for life itself. Plants need nitrogen to grow, and we get it from the food we eat, all thanks to those intricate nitrogen cycles.
So even though we don't directly use nitrogen for breathing, it's still super important for the whole ecosystem. Wow, that's pretty cool.
Exactly. Now let's move on to the superstar. Oxygen. It powers our cells, keeps us going, and makes combustion possible. Think everything from cozy fireplaces to, rockets launching into space.
But too much oxygen can be dangerous, right? I remember learning that things burn way more intensely in pure oxygen.
You're absolutely right. Oxygen loves to react, and while we need it to survive, the concentration in the air has got to be just right. Too much, and things get a little too fiery, too little, and we can't breathe.
So this atmospheric balance is pretty delicate, huh? It makes you wonder about the impact of things like pollution. What is all that stuff doing to the air we breathe?
Great point. We'll definitely get into that a little later, but first, let's talk about another important gas in the mix, carbon dioxide.
Oh yeah, CO2. Everyone's talking about it as a greenhouse gas and climate change and all that. But isn't it also a natural part of the air we breathe?
Absolutely. Carbon dioxide is produced when we breathe, and it's also a crucial ingredient for photosynthesis. Plants use CO2 to create energy, effectively recycling what we exhale. It's a pretty amazing natural cycle, really.
So it's not that carbon dioxide itself is bad, right? It's more about having too much of it, throwing off the balance.
Exactly. The disrupting this balance is where things get complicated. But before we dive into the complexities of atmospheric chemistry and pollution, let's pause here for a sec. What are your initial thoughts on the key players in the air we breathe?
I'm just struck by how connected everything is. Nitrogen, even though we don't breathe it directly, is still vital for life. Oxygen, as crucial as it is, can be dangerous in high concentrations. And carbon dioxide, which gets a lot of negative press, is actually essential for plants and a natural part of this cycle. It's like even the simplest things are way more complex than we realize.
You got it. And that's exactly what makes atmospheric chemistry so fascinating and crucial to understand. Ready to delve deeper into the reactions happening all around us in every breath we take.
Definitely, let's do it.
So, ready to dive into the reactions happening in the air. It's like this whole invisible world going on right around us.
Yeah, it is. It's kind of wild to think about all those reactions constantly taking place. What are some of the big ones happening up there? We talked about the main components, but how do they actually, interact?
Well, one of the most important is the formation of ozone. It's a pretty complex process involving oxygen, sunlight, and pollutants like nitrogen oxides.
Ozone dot, isn't that what's in the ozone layer? The one that protects us from those harmful UV rays. So how does that form, down here where we are?
You're right. Ozone is super important up in the stratosphere. But down here, closer to the ground, it's a different story. When those nitrogen oxides, from cars and factories, they react with sunlight and oxygen, and that creates ground-level ozone, a big part of smog, actually.
So the same molecule that protects us way up high can be harmful down here. It's kind of like a weird paradox.
It is. It shows how important context is. Up high, ozone's a protector. Down low, it's a pollutant that can really mess with our lungs and breathing.
Makes sense. And it also makes you think even clean air isn't always completely clean, huh? So much going on in there.
Exactly. And the reactions, they don't stop there. Atmospheric chemistry is always changing, always interacting. Like, for example, sulfur dioxide. Another thing from burning fossil fuels. It can react with water vapor, turns into sulfuric acid.
Wait, sulfuric acid, like stuff in car batteries?
Yep, that's the one. And it's seriously corrosive. When it's up in the air, it's a big part of acid rain, which can damage, well, pretty much everything. Ecosystems, forests, even buildings.
So these invisible reactions, they have real consequences, huh? It's like what we put into the air, it doesn't just disappear, it changes, and then it can come back to bite us.
That's a great way to put it. Air isn't just like a background. It's actively involved in all these reactions, some good, some bad.
Sounds like understanding atmospheric chemistry is key to dealing with stuff like, air pollution and climate change.
For sure. Scientists are studying those reactions to figure out ways to cut down emissions, deal with the pollution we already have, and hopefully make the planet healthier for everyone.
Wow. It's amazing, right? Something as simple as air can tell us so much about how our world is connected and the challenges we face.
It really is, and we're just scratching the surface. There's way more to atmospheric chemistry, particulate matter, volatile organic compounds. It's a whole rabbit hole.
My mind is kind of blown, seeing air in a totally different way, not just a bunch of gases, but a whole system full of reactions and consequences.
That's exactly what we were hoping for. And hey, this is just a taste of what cocktail party chemistry gets into. They go even deeper in the full episode.
You've definitely got me hooked. What else about atmospheric chemistry that we have in store for the final part of this deep dive? It's wild, right? We've talked about what air is made of, how it reacts, all that smog and acid rain stuff. So much going on right under our noses, literally.
Yeah, for sure. And there's still more to explore. Like, remember those other gases, the ones that aren't nitrogen, oxygen, or CO2? They might be small, but they're still a big deal.
Oh, right. What are those again? Anything interesting in that mix?
Well, there's methane. It's actually a way stronger greenhouse gas than the CO2, and it comes from all kinds of places, both natural and man-made.
Methane, that's the cow thing, right? I've heard about how much livestock impacts the environment.
Yeah, that's one source. But there's also natural gas leaks, landfills, even rice paddies. It's crazy. Methane's a real heat trapper, so even a little bit extra can have a big impact on global temperatures.
So it's not just about CO2 then, huh? We got to pay attention to these other gases too, like methane. It's a whole puzzle figuring out where they come from and how to, cut down on them.
Exactly. It's all about looking at the big picture when it comes to climate change. Can't just focus on one thing.
This whole deep dive's been a real eye-opener. Makes you think about air in a different way, you know? Not just empty space, but this whole system that's crucial for life on Earth.
It is, and it's always changing too. Think about volcanoes, for instance. When they erupt, they spew tons of sulfur dioxide and other gases into the air, can have a big impact on climate and air quality, both short-term and in the long run.
Whoa, yeah. Volcanoes are a good reminder that nature has a big impact too, right? We're not always in control.
Definitely. Figuring out how all that natural stuff interacts with, what we humans do, that's super important if we want to protect the planet.
This has been amazing. Seriously, I feel like I have a whole new appreciation for air now. Not just what I breathe, but all the stuff that keeps our atmosphere working.
That's what cocktail party chemistry is all about. They take these complicated science things and make them fun and easy to understand. Hopefully you'll walk away with some fun facts to share and a better sense of what's going on in the air around you.
I definitely will. Thanks for walking us through all this. Super fascinating. And for everyone listening, check out Cocktail Party Chemistry, episode 179, The Chemistry of Air, What We Breathe. You can dig even deeper into all this cool stuff.
Great. Keep breathing, everyone, and keep exploring. A CII.